Welcome to our exploration of hash functions and hash tables, fundamental data structures in computer science that enable efficient data storage and retrieval. Let's start with the universe of all possible keys. This represents an enormous set of potential data items we might want to store. The magic happens through a hash function, denoted as h of x, which takes any key from our universe and maps it to a specific location. The hash function maps these keys into a much smaller hash table with slots numbered from 0 to n-1. This compact structure is what makes hash tables so efficient. Now let's see how the hashing process works. We'll take several keys from our universe and watch how the hash function maps each one to a specific slot in our table. Here's key number 1 being processed by our hash function. The hash function determines it should go in slot 1, and the key is stored there. Here's key number 2 being processed by our hash function. The hash function determines it should go in slot 2, and the key is stored there. Here's key number 3 being processed by our hash function. The hash function determines it should go in slot 3, and the key is stored there. But what happens when two different keys hash to the same slot? This is called a collision, and it's a fundamental challenge in hash table design. Watch as this new key also maps to slot 1, which is already occupied. Watch as this new key also maps to slot 1, which is already occupied. One elegant solution to collisions is chaining. Instead of having just one item per slot, we create a linked list that can hold multiple keys that hash to the same location. This demonstrates the fundamental principles of hash functions and hash tables, efficient mapping from a large universe to a compact structure with smart solutions for handling collisions.